Change in velocity is negative. Do that over here. Between A and B, I'm going to stick acceleration up here, so it's, I seem to be getting farther and farther off as I go down here without grid lines. So it's negative there. Between B and C, what's my change in velocity?
0.
Thank you for being loud there. So change in velocity is 0, acceleration is 0. What about from C to D? I think somebody just said it.
Negative 15.
Yep, negative 15. So from C to D, it's negative. What about D to E? What's my change?
15.
Be careful about that. I understand why you said that, but recognize it's going to the left. That's negative 15 there. It goes from 0 to negative 15. So the change is negative 15. That's also negative 15, negative 10, negative 5. My change from E to F,
0.
from F to G,
Negative 5.
5. Think about get a number line that negative 15 here is 0, positive, negatives over here. Negative 15 to negative 10, I'm going in the positive direction. And so E to F was 0, F to G was positive, G to H,
Positive.
and then H to I.
Positive.
All right, so we have some sort of guideline here. And it matches the forces. Because remember, acceleration and force are in the same, total force and acceleration in the same direction. When it's going from A to B, I have weight acting down, I have normal force acting up, and I have friction acting to the left. These will cancel each other out. This force right here is to the left, it's negative. From B to C, there's no friction involved. Total force is 0, acceleration is 0. From C to D, there is a net force acting down the ramp. That's what slows it down and speeds it back up. This is just a milder case of throwing an object up into the air. At the peak, there's still that downward force acting. And then from F to H, I have weight acting down, I have normal force acting up, and then I have friction acting opposite the direction of motion. Friction is acting in the positive direction. And then up here, again, the net force is down the ramp, that's what slows it down. And so we can start to fill in some of the gaps here. At A, it's on friction, friction's acting back. B, it's still on friction. It's 0 along there. At D, it's still negative. E, that's when it's on the frictionless ramp again. F, it's just started to touch the friction. And then positive the rest of the way. So. And then over here, it was 0 from B to C. B to F. That's it. It was negative from A to B. And then after C, so between C and E, and then positive after F. Ms. Goff, did that complete you?
Thank you.
Questions? Amina?
I have a question for this test. It says, at what time did the object stop?
Oh, okay.
I don't know how to find that.
All right, any questions about this before I erase it? Brianna?
For the positive for acceleration, would F not be included?
F is not included because F, oh. No, F is included, oh, I left it on. You're correct. F is included, thank you. The advantage of this is that I would have noticed that there was a gap there.
With Amina's question, is there any way we can just go over that section just as a refresher?
Oh, for the one that Amina was asking about?
Yeah.
Sure.
Oh, thank you.
Okay. Other questions about this before I erase? Or comments about mistakes I've made? I do appreciate you bringing that up in class. I did something like this with, it was the 151 class this semester. And after class, someone came up and said, hey, didn't you leave off such and such? At that point, everyone else had gone. All right, so that was from some particular test. What were you given? Oh, okay. Thank you. Objects goes from 62 meters per second to negative 28 meters per second in 10 seconds along a straight flat road with uniform acceleration. And so I asked, what's the change in velocity, acceleration, average velocity, displacement, time of stopping, how far did it travel from start to stop? Not the end of the problem, but when it actually stops at this time. And then distance traveled, and then average speed. There you go. Because it turns around, I know that this will be larger than this. And I guess I use X one place, S another. It should probably be more consistent there on an X. X. So displacement is where does it end up relative to where it started, and this is the actual, how far did it actually travel. So it went some distance in the positive direction, and then went some distance in the negative direction. So we'll get it step by step. Change in velocity. Again, how do you find change? Yep. So it's negative 28 minus 62. That's my change in velocity.
Do you divide that to
Pardon?
Do you divide that to
No, you don't. Change is just you're subtracting. And so that's
90.
negative 90. So negative 90 meters. Again, think number line, I'm on the positive side, and I go to the negative side, so my difference is negative. Acceleration is just the change in velocity divided by how much time it took. So whatever I got here, I'm gonna divide by the amount of time, which was 10 seconds. So this change in velocity, which you already solved, over change in time. So negative 90 meters per second divided by 10 seconds.
Negative 9 meters per second.
Now, average velocity, this is the one that if acceleration is constant, which it is because it says so in the problem, you're just averaging the first and last. You now average these numbers. This is when you divide by the 2. So it's just my initial plus my final divided by 2. It's also equal to the displacement divided by time. So if we were given displacement and the time, we could have found average velocity with that. But in this particular problem, you weren't given that information. So we have to use this formula. So it's just the average of 62 plus negative 28 divided by 2.
17.
Which is what?
17. Meters.
So displacement, now we're going to use the second part because I know what the average is, it's 17, and I know that the change in my displacement over time is equal to my average, which is 17. I know time, that was given to the problem. So displacement divided by 10 is equal to 17. So what's the displacement? And please don't forget units.
What you say, how you get 170?
My displacement divided by my time is equal to 17. So mathematically, you would divide both sides by 10, that's what's just said over there. Or what divided by 10 gets you 17? And if we were in the old room, it would look like this every time. All right, so what's happened here is, I'm just gonna assume that to the right is positive. It's not specified in the problem, all I know is that it starts out in the positive direction. So it starts out going in the positive direction, it's gonna, because I know that my initial velocity is positive, and it ends up in the negative direction, so it has to turn around at some point. So it's going to go out, turn around, come back, and at the end of the problem, my displacement is positive 170 meters, which means that I'm 170 meters on the positive side of where I started. So the next two questions about what time does it stop and what is the displacement from the start to the stopping, this is setting up to find the distance that was traveled. So we need to figure out the time. I know it's going 62 meters per second here. It's going 0 meters per second here. That's what stopping means. Well, I have one piece of information. I know my acceleration. Acceleration is the change in velocity over the change in time. There's another way of doing it. I'll do it as a different way in just a moment. But if you're going to pull that information over there, I got negative 9 is equal to, again, all I'm looking at is just this first part. As it's traveling this way, What's my change in velocity?
62 to 0.
Negative
62 to 0.
So the change is,
Negative 62.
yes, negative 62 divided by however much time it took. And so the math problem is, well, I turned this into a fraction, I got equal fractions, cross multiply, whatever you want to do it, but it ends up being, the time is negative 62 divided by negative 9. Which is,
Like 6.89.
seconds. Acceleration is telling us how the velocity changes. So if I looked at it a different way, so I have time in seconds and I have my velocity in meters per second. I don't need that far, but it starts out going 62. After 1 second, my change is negative 9. It's negative 9 meters per second every second. So I subtract 9, so that's 53. 44. 35. 26. 17. 8. Negative 1. My change is negative 9 every single time, every second. So I know that it stops somewhere between when it's going in the positive direction to when it's going in the negative direction. So it's going to be somewhere in here between 6 and 7 seconds. Matter of fact, it's going to be closer to 7 seconds because, well, that's at 8, that's at negative 1. It's got more to travel in the positive than the negative here in this. And at that point, it's 6 and 8 ninths. Was that a sound of realization or, okay. So that's the time. Now, whether you keep it as a improper fraction, if you keep it as 62 ninths, that's a legitimate answer. Or you put it down into decimal, or you take it out several more decimal places. Flexible there. The 8 repeats. So the next question is, how far does it go to stopping? I now know the time. The time is 6.8 repeating seconds. Well, you've already gone through the process once. It's just different numbers this time. The simplest way probably is to take my average and multiply times time. What's my average velocity in this moving to the right?
17 meters per second.
That's for the entire trip. This is just for moving to the right. I think somebody said it.
36.
Nope, a little off. If it started at 72 meters per second, you'd be right.
31.
Yes, 31. My average velocity, 31 meters per second. And I do that for this 6.8 repeating seconds. So you just multiply them. On average, I'm going 31 meters per second for 6.89 seconds. You multiply. Pretty much what we did right here, where we multiply the average velocity times the time. The seconds. And so what is this? 217?
213. 213.
213.
Wait, 5. 6.
Units?
Meters?
Yes. I'm about to erase part of this. Any questions up to here? Nina?
So for the 2 right there, that's just part of the formula?
Yes, for finding average velocity, yes.
Okay.
Assuming if acceleration is constant, then yes, it's just, you're averaging, so you take 2 numbers and divide by 2.
So if it's not constant, then it'll be something different?
Yeah, then you have to do it this way, or there's some more complex ways of doing it. But if acceleration is not constant, this is the only way to find average velocity. Trying to think if I subjected you to that. Sort of, kind of, but not really.
What do you want us to get that 213.56?
It comes back to my average velocity is my displacement divided by time. And so my average velocity we figured out was 31 meters per second. That's equal to my displacement divided by 6.89. And so basically multiply both sides by 6.89.
Okay.
The question, Amina?
How did we know that it was, the average velocity was 31?
Because acceleration is constant, so we just basically average these 2 numbers here. That's all it was. Since the trip was from the beginning of the problem to when it stops, that's why I picked those 2 numbers.
Why is it 213.56 when it's 213.59?
Oh, I thought I heard, did I mishear?
I rounded up, it's 559.
559? Okay. You prefer the extra level of precision?
No, it's cause I got 5.9, I didn't get.
Oh, you didn't get the 559?
Yeah.
I got
It-
5.9.
Yeah, it depends on where you round off. If you treat this as 6.9 or 6.89 or 6.889,